Hello, my name is ABDUSSAMED. Welcome to my channel. Today I am discussing about FHP motors, that is fractional horsepower motor. This indicates motor having below 1 HP ratings. In FHP motors, there is many classification. In this today I am discussing about single phase induction motors. First of all, I am discussing about the classification of single phase induction motor. There is 5 classification. In this one, the first one is split phase induction motor. It is also called resistance start induction motor. And the second one is capacitor start induction run motor. The third one is capacitor start, capacitor run motor. And fourth one is permanent split capacitor motor, and the last one is shaded pole induction motor. This all, you see the similarity in the names. There is small changes. If we make small changes in the circuit, we can make all these motors. Okay, I will explain each and every motors separately. First of all, split phase induction motor, that is also called resistance start induction motor. All the motors, there is stator and there is a rotor. Here the rotor is, this one is the rotor. It is squirrel cage rotor. And the stator, there is two types of stator is there: main winding and auxiliary winding. The main winding is also called the running winding. The auxiliary winding is also called the starting winding. You see there is one centrifugal switch. Centrifugal switch S is here. It is connected in series with the auxiliary winding. In this one, the starting winding has high resistance. The current passing through the starting current or auxiliary is IS, and current passing through the running winding is IR. From the vector diagram, this is the voltage across the winding. This is the starting current IS. This is the running current or main current IM. Okay, here the starting winding and the running winding has its resistance and reluctance is different. First of all, we can look the starting winding. It has high resistance but low reactance. So the current flowing in the starting winding IS lag the applied voltage V by a very small angle. From this we can see, you see from the vector diagram, there is small angle. There is small angle between the voltage and IS. The second one, running winding. Running winding has, you see, it has a low resistance but high reactance. The current flowing in running winding lag the applied voltage V by a large angle. You see from the figure, from the vector diagram, the voltage and IM, it's very high angle is there. Okay, the torque developed is proportion to the sine of the angle between IS and IM. I call the angle as alpha. This is IS and this is IM. This is the angle between IS and IM. I call this alpha. You see it is about 30 degree. That is very small angle. Due to this, this motor has medium starting torque. It is approximately on two times that of full load torque. The motor starts and it runs when it reaches the 70 to 80% of its full load speed. The centrifugal switch S is automatically open and it disconnects the starting winding from the supply. Okay, it is available in the size ranging 1 to 20 to 1 by 3 HP. that is 40 to 250 watts. The application of this motor is it is used in fans and blower, in washing machine, in small machine tools, in refrigerator, oil burner, air conditioning fans, mixer grinder, floor finishers, centrifugal pump, drilling and lathe machine. The second one is the capacitor start induction run motor. Same we explained before. It has a rotor. Rotor is squirrel cage rotor. Stator, two types, main winding and auxiliary winding. Main winding is also called running winding. The auxiliary winding is also called starting winding. Okay, and there is one difference from before. There is one capacitor is here. It is connected in series with the starting winding. That its name capacitor start. The capacitor is connected in series with the starting winding. That is name called capacitor start. And then centrifugal switch. Centrifugal switch is connected in series with the starting winding. The main winding is highly reactive, and the starting winding is capacitive because there is one capacitor is there. The current passing through the starting winding is IS, and the current passing through the main winding is called IM. It is called IM. Okay. The starting because of the starting winding has the high capacitance, the current flowing through the starting winding will lead the voltage by an angle, by a certain angle. And the IM, you see, from the running winding has high reactance. The current flowing in running winding lag the applied voltage V by a large angle, the V and IM. And the torque developed is proportion to, same we explained before, it is proportion to the sine of the angle between IS and IM, that is alpha. You see, this is IS and this is IM. This is angle alpha. You see, from before we explained in the resistance start induction run motor, the angle is 30 degree. Here the capacitor start induction motor, the angle is 80 degree. Sometime it will be 90 degree. That is, the angle is increasing, and the angle is increasing, sine alpha is also increases. Thus, the starting torque will increase. It has high starting torque. It is approximately to 3.5 to 4 times that of full load torque. There is centrifugal switch. It is automatically open when the motor reaches to 70 to 80% of its full load speed, and it cuts the both starting winding and the capacitor from the supply. It is available in the range of 1/6 HP to 3 HP, that is 120 to 2500 watts. The applications are: it is used in pump and compressor, it is used in refrigerator, it is used in air conditioning compressor, it is used in conveyor and machine tools, it is used in elevators where we need high starting torque. The next one is capacitor start, capacitor run motor. Capacitor start, capacitor run motor. You see, there is construction. Same, there is one rotor is there. It is squirrel cage rotor. Its stator has two windings, main winding and auxiliary winding. And it has two capacitor. There is CR and there is CS. Two capacitor is there. Because of this, it is called a two value capacitor method. There is two capacitor is there. There is one switch, centrifugal switch is there. There is starting switch, and it is connected in series with the starting capacitor. And the starting capacitor is used only for the starting purpose. that is, it is short time rated. It is electrolytic because a large current is passing through. A large current is needed to obtain the starting torque. So the value of the starting capacitor should be large, and the rated current is smaller than the starting current at the normal operating condition of the motor. Hence the value of the run capacitor CR should be small, because the running current or the operating current, rated current, is smaller than the starting current. For this, the capacitor CR should be small. It is long time because this capacitor is permanently in the circuit, and because of this one, it is constructed. It is oil filled vapor capacitor. Same we explained before. As the motor reaches 70 to 80% of its full load speed, the starting capacitor CS is disconnected from the circuit by a centrifugal switch S. The capacitor CR is connected permanently in the circuit. It has higher efficiency and power factor. The starting torque is very high. The motor has very less noise. Also, motor runs smoothly. These motors are costly. Applications of this type of motor is, it is used in pump, it is used in refrigerator, it is used in air conditioner, it is used in compressor, it is used in conveyors. The next one is permanent split capacitor motor. The construction same as before. It is on rotor. The rotor is squirrel cage rotor, and the stator has two types: main winding and auxiliary winding. Main winding is also called running winding, and the auxiliary winding is also called its starting winding. There is one capacitor. One capacitor remains in the circuit permanently. There is no centrifugal switch. You see, from the before the three motors we explained, there is one centrifugal switch, but here there is no centrifugal switch. The same capacitor is used for starting and running. The value of capacitor CS should be small. It is long time rated. It is oil filled vapor capacitor. It is the low value of the capacitor result in the small starting torque. That's why the starting torque is very low. Its application is used where we need only the small torque is required. It is used in fan, it is used in blower, it is used in voltage regulator, and it is used in oil burner. The last one is in this type of single phase induction motor is shaded pole induction motor. It is very popular for rating below 0.05 HP because of its extremely small construction. We can look the construction. There is salient pole stator. Salient pole stator is there, and a squirrel cage rotor is there. Because this squirrel cage rotor, due to this one, there is no commutator, no brushes, no collector rings, no contactors, no capacitors or moving switch parts. It is relatively cheaper, simpler, and extremely rugged in construction. Then we can check the salient pole. Salient pole, you see, this is a larger portion of the salient pole is this one. This one, there is two portions there. There is shaded portion and unshaded portion. This shaded portion is surrounded by a short circuited turn of copper strip. It is called a shading coil. This shaded pole, sometimes it may be 2 poles or 4 poles. Here it is 4 pole. And the starting torque, efficiency, and power factor are very low because it is this all things is very small. The starting torque, efficiency, and power factor are very low. There is no centrifugal switch. Due to this, it eliminates the possibility of motor failure due to faulty centrifugal switch mechanism. Application of shaded pole motor is, it is used in small fans, it is used in toys, it is used in hair dryer, it is used in advertising display, and it is used in film projectors. This is very important, this one, it is used in toys. Okay, thanks for watching. Subscribe this channel for getting more videos.